Please put your attendance. You may please put your attendance. Okay, so you continue. I'll be starting, I'll be showing about the content, what we are going to discuss today. Basically, this chapter I will be focusing from the textbook itself. It is sufficient for information, and we need not really worry about the content. So basically, when I'm talking about sterilization, we are going to talk about why is it required, right? Why sterilization is required, and I yesterday I told about that. So it will support the growth of organism, okay, and the contaminant resulting in loss of productivity. So if someone is growing, your product will be lost. So I need definitely sterilization. Outgrow is possible. Outgrow means if both are growing happily, possibly you may still allow. But outgrowth means it is suppressing the growth of your original organism and growing further. That cannot be permitted, right? Then eventually you will lose everything. So it will be just invading that media. It is not really possible. It will be always contaminated. So there is a loss of contamination, and contaminant may produce compound which is subsequent extraction can be difficult. So your pathogenic organism may produce something which you want to remove. That aspects can be really difficult to do if I'm not going for this process. So avoidance is always good idea. Now here we are talking about the sterilization. In our last class, if you remember, I told that sterilization is like any sterilization means killing microorganism. That process is like firing, as I told you. Is more number is there, anytime you will have more death. If less is there, less death. So it is actually a probabilistic event, right? Increasing probability of death. So that's why in our last class I told death rate for any process, moist state, or we are going for UV treatment, UV sterilization, always the death rate is going to be proportional with current number. Okay, this concept should be always keep in mind. Other things are really not so important here. And I will talk about how is it going to give some important aspects in sterilization, why you need to bother. So that aspects I'm going to talk in today's class for some time. Okay, my screen is already shared, I believe. So I'm coming to a point. I think, okay. So I'm just starting this discussion here. Okay, so what we are going to have little mathematics on sterilization. It is really important for us to know this and how we are going to get sterilization ensuring. First of all, as I told you, for any treatment process, any sterilization, the rate of death is going to be proportional with the current number. And if I remove the proportionality constant, I can write K n. N is the, remember, n is number of live cell at any time. Okay, because cell will die, right? When you are sterilizing, cell will definitely die. This is only part of the death process. That means if I'm doing some heat sterilization process, the number of cell, how it will fall can be given by this. And this kinetics, you know, if you have any knowledge on kinetics, this is called first order kinetics, because rate is proportional to the number, right? If rate is proportional to the number n power 1, n is means n power 1. So this is a first order. So this is a first order kinetics for death. Now, can I do something in this equation? Yes, I can reorganize it. dn by n equal to minus k dt. If I do a integration, you can do. For example, I'm starting with n0. I'm having this many biomass, and I'm looking for some number, any number n, and I'm saying time is 0 to time t. So what will happen? It will be simply simplified. You can do ln nt minus ln n0. That is means simply I can say nt by n0. I can write equal to minus k into t. If you want to have just reorganize the expression, I can always say nt by n0. Nt means number of live cell at any time, whatever time I'm talking, time t, and n0 is the starting point. It will be always e to the power minus kt. I hope I'm correct. So you can rewrite again nt equal to n0 into e power minus kt. So that means if I tell you that I am starting with this many number of cell, and my k value, the death rate constant is given, and I am asking you how many cells will be there after 1 hour, 2 hour, or 3 hour, like that, you can definitely tell us, right? Am I clear? You can always tell us how much is the number. Now, basically, why is this important, and how is this implications? This is really having very important implications. This is calculation is not so important. Let me come to one simple calculation here. For example, I am having a culture broth and you are doing a sterilization. I'll ask you some numerical aspects. For example, I am having initially 1000 bacteria is there per ml, for example, initially. After, so it is being killed, right? So for example, after 1 minute, okay, after 1 minute, I am having some 100, for example. So this is at time equal to 0. This is time equal to 1. Why it is come down? Because they are dying, right? Yes or no? They are
Yes,
dying.
sir.
Okay. So can I put this equation, whatever I already learned? Nt by n0 equal to e to the power minus kt. So nt means time equal to 100. n0 starting is 1000. Yes or no? And equal to e to the power minus k I don't know, I can find out, and time is 0 to 1, time is 1 just. So I can say what is becoming this one? This is becoming 1 by, so 100 it is 1000, 1 by 10 e to the power minus k. Okay, very good. Now that you understand that this is the value for k. Now if I ask you simply, because this is a first order, right? After another 1 minute, if I say at time 2, what will be the number? You see, because time gap is always here also 1 minute. So the ratio should be, for example, this case, ratio is 1 by 10. So here also it will become 1 by 10. So 100,000, 1 by 10. Next time what will happen at t equal to 3? It will become 1. At t equal to 4, can you tell me? Of course, you will say, sir, 0.1 bacteria is possible. Of course, not possible. But what does it mean? It means that if this is the case, that I am having some 1000, 100, 10, 1. So what do you think? That the number falling is always going to be decreasing, right? In a logarithmic manner. Or exponential decay, rather, I can say, not logarithmic. Exponential decay, I can always say. So this decay is the number, live number, and this is time. Do you think you can get any time 0? Never you will get 0. Then you will have 0.01, you can have 0.001, but you can never reach 0. That is the process for any first order reaction, any first order kinetics. You can never reach 0. Of course, then you'll say, when I will reach 0? Of course, at infinity time, but infinity, you know, you don't know that what is infinity actually. So infinity time you can reach, then you will have 0 number. Then question comes, then if this is the process, for example, in one case I am getting 1000 is becoming 100, 100 is becoming 10, that way is going. Or simply I can have another approach. For example, I am having 1000, then it is becoming 500, then it is becoming, you understand, na? The same ratio, 250, then 125, then 62.5, for example, then 31.25. This way, for example, this is taken 1 minute. So this will also take 1 minute. This will also take, so you see, at the very beginning, around 500 cells are dying in 1 minute. Next 1 minute, only 250 are dying. Next 1 minute, another 125 is dying because 50%. Next 1 minute. So what is happening? The number of cell dying is actually decreasing, and you will definitely have, this is the first order decay. Am I clear? Now, if you understand?
Yes, sir.
Okay. So this way it will always go and you will never reach 0. Then my question is that how can I reach sterilization? When I mean to sterilize, what does it mean for us? The first question is that you can never have sterilization 100% in any possibility. Then what should be our judgment? We normally put, for example, if I say I am having one conical flask and I am starting with, for example, 1,000 cell or 10,000 cell. I am asking a very simple question, and I am giving you the K values possibly. So I am starting with 10,000 cell and I want to sterilize it. So how much time it will take? Because, for example, if I give you the K value, you can do the calculation. So for example, K equal to 0.15, for example, just I'm talking. So you already know, I told you the formula. Formula is NT equal to, so for example, NT equal to N0 into e to the power KT. So what is my expectation? From 10,000, what is my expected number I want to have? 1? No, 1 is not good. 1 spore is not good. Can I say 0.01? Then you will say, sir, bacteria, how it can have fraction number? Number of people, number of bacteria cannot be fraction, na? Then why I'm talking about 0.01? You see, 0.01 is not practical, but it has a meaning. 0.01 means out of 100 batch, in one case, I will find one bacteria. So I am talking about only one flux. But if you see this picture in a statistical sense, you can also appreciate that, sir, if I am doing this process in 100 flux, 100 different conical flux I am taking, this means, this attainment means actually out of 100, in 99 nothing is there virtually, but in one flux it is there. So it is actually 1 by 100. So what does it mean? It means 99% chance that your sterilization process is successful. So we will normally try to have a bacterial load of like this, small 0.01 and like that. We want to have it. Okay, so this is, it may look like that, okay, fraction number is not correct, but you try to explain this way. When I'm telling that my target number is 0.01, it does not mean that I'm looking for 0.01 fraction of a bacteria, right? No, I mean to say that if I am doing this process in 100 flux, out of the 100 flux, in one flux only I will find one bacteria, in other flux I will not find. That guarantee I am putting. So from this introspection, you can always tell me the time required, right? I told you what is the time requirement. Use the formula. What is the formula? Kt equal to minus Kt equal to ln Nt by N0, or you can simply say Kt equal to minus Kt equal to ln Nt by N0. So Kt equal to ln N0 by Nt. So I can simply say Kt equal to ln N0 by Nt. N0 I told you, sorry, this slide I was doing, na? Okay. N0 by Nt. N0 I already know. So ln, for example, 10,000. Nt is, for example, 0.01. Okay. So I can have 10,000, 0.01 means ln of 10,000, another 20 will come. Of course, big number. You can do the calculation. And then I'll divide it by k. K equal to, for example, 0.15. So I'll get the time. So time calculation from depth kinetics is really easy. It is not really a difficult job. Simple mathematics is involved when I'm going to do. But okay, that is all understandable. Then what is important? Important is, you see, in any depth kinetics, there is always one consideration that is called half-life. At what time the number is becoming 50%? So 1000 to 500, how much time it will take? That is constant. Or 500 to 250, how much time it takes? It is constant. So if I say there is some parameter, we can say half-life. Similarly, we will also have a term that is called del factor. Okay, del factor means we are going to talk about what will be in the depth number which is going to happen from one steps to another steps. So change in number you are expecting, these things can be easily represented. So I think I made you understand at least this concept. The fractional change will take same time. 100 to 10, how much time? Do not reduce, do not subtract. You simply assume how much fraction. So 100 is becoming 10. So 1/10. 10 is becoming 1. This is also 1/10. It will take same time. 1 minute, it will also taking 1 minute. So for first order, the ratio of change remain constant, not the number. 100 to 10 means you do not assume that 90 killed, not like that. So this way you can always identify, you can always find out how can you have a better perception on sterilization process. I'll go to the text also. You see, when I'm talking about Nt by N0, what will you see? The number is always falling slowly. If I do logarithm will be always straight line, because I already told you here. You see my equation, ln Nt by N0 equal to minus Kt, right? If I make a graph between ln Nt by N0 versus T, what will happen? It will be like y equal to mx, right? You can understand. So for example, I have done this and I'm just going to utilize this. So for example, this is my y of a graph and time is my x of a graph. So can I say y equal to mx? So what is m? M is minus k. Yes or no? So this is m. So if I make a plot of ln Nt by N0 versus T, I'm going to suppose to get a straight line whose slope is m. So m is the slope of this graph. And that is actually minus k. It is negative slope. So from the slope, I can find out what is the k value. It is easy, no issue. So graphically, you can find out, or whatever method you want to apply numerically. These calculations are really straightforward and it is not difficult time. So this process, ln Nt by N0 equal to minus Kt, is really a kinetic description. You can understand at any situations. I will show you some graphs. First of all, you see, if I do a plot of ln Nt by N0, I may find that it is actually increasing and then falling. Why it happens? Why do you think this is happening? First reason is that when I am heating it up, I'm having some culture, right? And I start heating. Initially, the heat is going to activate its growth. Try to understand. Providing a little bit of heat is always good for microorganism to grow. So little bit heating will actually increase its growth rate for some time. But after very soon you will see that that improvement is no longer important. So this initial rise in number is actually due to promotion of growth due to temperature. But it is not always good. If I increase more temperature, plants grow in winter or summer. They grow better in summer up to some time, because always the more radiation, more heat is there, growth is good. But if there is a scorching heat, what will happen? Many plants will die out. So same thing happens in sterilization. Initially, some amount it is beneficial, then death. So this graph is talking about increase initial phase, early spores can actually get activated and they will die. So this is the way normally it will happen. And you see there can be another graph has shown, that is they are talking about two kinds of microorganism. One microorganism they are assuming is sensitive, another microorganism they are assuming is non-sensitive or resistant. If because your culture can have both the organism, you may overall find a composite structure. It is not always falling. So someone is really falling, some microorganism is really dying, some microorganism is very slowly dying. But what you will actually see, you will see the overall picture, you cannot identify the microorganism. So sometime you may find a graph like this. So initial falling, then smoothing. So if I do, then question comes, sir, how do I get this graph first of all? Yeah, very good question. How can I get this graph? Can anybody tell me how can I do the sterilization study? If I want to do the study itself, how can I do that? Forget about theory, I'm talking about practice. How can I have opportunity to do the sterilization study is really, you'll find it is really interesting. First thing I need to understand when I'm going for any sterilization, how normally people do. Let me talk on that. For example, I'm going to do some sterilization with my culture. Okay, I'm having some culture. I'm taking 1 ml or maybe some less than 1 ml and I'm putting on a plate, maybe some nutrient agar plate is there, and I'm counting how many colonies will come. They will not come immediately, they will come next day, no issue. And it is in a autoclave. So before starting the autoclave I am taking, and I am having multiple units, multiple flux I am having. So one flux I am just before experiment I am doing, one same flux, same kind of flux after, for example, after 15 minutes I am taking it out from autoclave and I am also again doing the plating, for example. Another flux I am taking out after 30 minutes. And you can also do the how many numbers are coming. Okay. So basically you can actually measure by plating those culture after 15 minutes, 30 minutes. And so basically you can have the plot how number is actually falling. Okay. And this is going to give you the graph idea of number of bacteria versus live. So because only live bacteria will grow, so that means I can find out how many are there in the live form, because live will only propagate, live will only grow on the agar plate. So this is the way normally people will do the experimental part of getting how many are live or dead. And if I'm talking about a media which may have multiple organisms, you understand. So someone is dying very happily, fast decrease is happening. Someone is dying slowly. So what you will see, your picture will be sum of this plus this, right? Both. So you will see, you will actually see the picture something different way. You will see the total number is falling like something like that. Okay, this will be your observation, because I am assuming there is two kind of bacteria, one is A, another is B. B is dying very fast, but A is dying very slow. The same phenomena has been shown in your textbook also. This may happen when I am going to have mixture of microorganism. We may also have some sterilization may be like this. So initial phase, the number is not changing. Why not changing? Two reasons. In this period, it may happen, I told you, when I am heating up, it is actually giving some promotion. They are more growing. So it is actually improving the growth to some extent. But some cells are also dying. So both are there. So you are getting something also, you are losing something also. If they are balanced, so how many is new spores are growing, regenerating, and how many cells are dying, if the increase is same as decrease, then what I will see, normally I will see that it is becoming nearly flat, not much change. After that, slowly, death is becoming more. So I'll find, okay, it is falling. You got my point? So this may also happen to make sometime flat curve. Flat curve means during this period, both things are happening and then microorganism is dying. So death curve kinetics data is really important to tell you what is the phenomena going on inside a microbial culture during the sterilization process. So I'll come to your textbook also, you see. Sometimes they are saying constant, then falling. So constant period means it is not constant. It simply implied that during this period, number is not really going to change. The number of increase and number of deaths are nearly balanced. Okay? Do you get the point? Here also same thing. You see, here it is not constant, but at least slow death, then fast death. Slow death and fast death means growth rate is also falling and death rate is also more. So we can always have a point of here it was actually compensated, but here it may not be compensated. So initial population decline at a sub-maximum rate during the sterilization treatment due to death of spore being compensated by heat activation of spore. So somehow initial phase looks like short, but finally it reaches the same one. So basically, it does not really talk about what is the process. It is just talking about what could be the possibility when we are going for a sterilization in our lab. This up to this point, you need to understand that sterilization remain as the rate is really very important. If I am having high death rate, so number of death will be more, you can achieve it more faster. You got my point? So K is really going to be very important, because I told you if K is more, my time will be less. Yes or no? I hope you understand this part. K is a intrinsic property. You cannot really have much control on that. So what you learned till now, that Kt equal to ln N0 by Nt, right? That I told. So for example, I want from 10,000 or 1,000 to 1. I want. That means 1,001. Now I'm giving you two situations. I'm having K is 5 one time, another time K is 2. So what will happen? You see, N0 by N is fixed. I'm having Kt. So initial K is 5, some T equal to whatever may be. I need not calculate. That is simply ln 1,000 by 1. You do your calculation. And second time I'm telling my K is 2 and how much time it will take. So T2 and T1. This is same, ln 1,000 by 1. So if I'm giving you two opportunity, having two different K, you can always understand that time will be just inverse, because this part is fixed. So if this is same, means this is also same. 5T equal to 2T1, simply 5T1 equal to 2T2. So if I say in the first case, I require some 3 minutes. So if I say 5 into 3 minutes, then this case I will require 2 into T2. So T2 will be 3 into 5 by 2. So 7.5 minutes. So you understand? So increasing K will decrease time and decreasing K will increase my sterilization time for same outcome. Outcome is 1,000 to 1. You see, this is the outcome. So if you have some specific outcome, K value can determine how long it will take to do the sterilization process. And this is really very important to understand in this perspective, so that you can understand. But another point is also there. These are all very important until or unless we are talking about the death rate constant remain constant. Okay, we are normally assuming that K is constant, but the rate of reaction is also not constant. Okay, K is not a constant. K is also depending on a function of temperature. And you also have one very important equations for any kinetics. I don't know, you have not studied till now thermodynamics. We will be teaching you that rate of reaction also depends on temperature, and that is given by Arrhenius equation, right? Any chemical reaction, if I found out the rate, it is going to be dependent on temperature. And we can have very simple equation. You may please remember that K is a function of temperature. K equal to A into e power minus E by RT. What does it mean? What is K? K is rate constant. You can find out. A is Arrhenius constant. This constant is not a universal constant like R. This constant is valid only for your system. And then T, this T, okay, I'll write it. So what I am writing, K A is Arrhenius constant. E means exponential, right? Like we are writing na, e to the power. This is exponential. And this E is actually activation energy of the reaction. Activation energy of the reaction for a given chemical reaction is constant. It is not going to change. It is constant, but not universal constant. So A and E are constant for a given reaction. R is universal constant, you know, right? 8.314. T is temperature. So what I am finding? I am finding that K is going to be a function of temperature. If I take ln of K, logarithm I am taking. So what will happen? It will become ln A, and you understand ln and E are neutralizing itself, minus. Am I clear? So this equation I am just making little bit treatment, logarithm, both side. This side also I am logarithm I am taking. Here also I am taking a logarithm. Logarithm of two things, x into y. What does it mean? Ln of x plus ln of y. Now ln of this part, it will be simply ln and E are there. So this is just complementary treatment. So it will become minus E by RT. So what does it mean? A is constant, E is constant. So if I find out the rate in logarithmic scale, so if I assume this is my y and 1 by RT, 1 by T is my x. Okay, then what will happen if I make a plot? You can also tell me. For example, this plot I am making 1 by T. T means temperature. For example, 20 degrees centigrade. So what is T? T is temperature in Kelvin. That means actually 293 temperature. So 1 by T equal to 1 by 293. So this is the point I am going to talk about. Ln K you calculate. So what will happen? I will find, if I make a graph, I will get like this. And you understand y equal to, so this is x. So M is this part. Okay, mx plus c, this part. So what is my slope of this graph? E by R, of course, minus E by R. And what is intercept? Ln A. So basically, intercept value is ln A. This is actually ln K. Axis is ln K. So what I'm going to say is that the rate constant actually depends on temperature also. Now, if I talk about this thing, your problem is becoming more problematic. Yes or no? Now, why we are learning this? Why we need to know that? This is also very important. Now, if I say you one simple thing, simple problem, what we will learn from this, and for numerical understanding, I think I will not discuss everything today, but at least I will try to make you understand one simple logic. For example, I am telling that you are sterilizing, for example, E. coli culture. Very simple, that is coming into my mind. E. coli culture, you are sterilizing at, you can sterilize at any temperature. Na? For example, you are sterilizing at 120 degrees centigrade. And it is taking 30 minutes to achieve from 1000 CFU colony forming unit microbial biomass into 1 or 0.1 CFU, whatever. Now I'm asking, if I do the sterilization at 200 degrees centigrade, how much should what should be the time, right? How long rather? How long should I sterilize? If I ask these questions, then you need to have both the information available with you. If you do not have the information, you cannot do that. So basically there is two situations. This is the first situation and this is the second situation. And how you are going to do that? Very easy. Coming to our main calculation, what I called K T, you remember I told equal to ln number 0 by number final, whatever you need. In both cases, my requirement is same, from 1000 to 1. Yes or no? 1000 to 1. So basically n0 by n is same. This is, for example, I'm talking about. If you have any difficulty in understanding, you let me know. And second equation also I told. What is that equation? That is for our K value. What is K? K equal to, you understand, K equal to A into exponential minus E by RT. Okay, I'm just keeping it for time being. So K1 equal to A into e to the power minus E by R, temperature 1, first temperature is 120. So I will just calculate it as 120 degree. Same thing I will do for second situation. This is two information you have. And second situation I am assuming K2, A e to the power minus E by R. Second temperature, that is actually 200 degree. So T1 equal to 100 degree centigrade. I have to convert it to Kelvin. T2 is 200 degree Kelvin. So I have just written these two equations, and your job is now very simple, because you see ln n0 by nt is my same. That means I am looking for K1 T1 equal to K2 T2. So I already from this equation I can write K1 T1. That means if I simply multiply this one with time, that means I'm talking about K1 T1. That should be equal to K2. K2 is this part into time T2. So this one equal to this one. So essentially A is gone, no issue. So you see, I'm having very simple E power minus E by R T1. Here E by R T2. T1 multiplied. So just rearrange it. You don't get panic from this calculation. So I can just say I'm having, okay, just let me see. E minus E by R T1, first part, into time 1. Same thing I am writing, E by R T2 into time 2. Just organize, nothing else. So I can say like that, ET1 minus E by RT1 divided by e to the power minus E by R T2 equal to, just you see, changing, and exponential of something divided by, so x5 divided by x square. So what does it mean? 5 minus 2, right? So it will be writing exponential of minus E by RT1 minus, another minus will come, subtracting, but essentially it will become plus E by RT2 equal to E2 by T1. So if I put simply ln, so it will be very easy now. So this part is coming minus E by RT1 plus E by RT2 equal to, now it will become ln of T2 by T1. Okay, we have done so much. Now you can take a little rest. E value I must give you. If I don't give the E value, you cannot do any calculation further. So I must tell you what is the activation energy. So E is known, I'm giving you. R is 8.314, universal gas constant, you know. Temperature 1 is 100 degree. That means 373 Kelvin. Second temperature is 200 degrees centigrade. That means 200 plus 273. Time 1 is known. Some 30 minutes I told, something I told. You can just do. How much time it will take? You can calculate. So basically, this calculation is becoming a mathematical problem when I am going to learn about this. So basically, whenever you are learning about sterilization, you please keep these two fundamental relationship. Your all problem will be solved. This equation and K1 meaning in terms of A into e to the power minus E by R T1, that two things you are required. So you need to know about K, you need to know about time, you need to know about temperature, and all other things, all other calculations will follow in the same line. I think I will stop it here because I had no intention to flood you with all the mathematics right now. Just for basic things, you keep these informations. AT expression, and K is rate constant. Rate constant is also depending on temperature. It is not a universal constant. So how is it going to change? This picturization is important for you. I'll stop it here right now and we'll discuss in our next class. You have any questions you can ask, otherwise you may leave.
For this PPT, will you be sharing, sir, in the GCR, sir?
This PPT?
Yes, sir.
This PPT is already there in the Google Drive.
So it will be updated there, no, sir?
Yes. Every day basis it will be updated.
Okay.
So whatever you have taken yesterday, that is not reflecting. So you have to check it today.
Yes, sir, I'll do it. Thank you.
Yes.
Thank you, sir.
Thank you all.